So that's basically installing the container stack there that runs the monitoring services of the cluster, the health checks, the API, the command line interface. As I said, it can be a single instance, but for high availability, it will be typically three small nodes. I think those have 2 or 4 vCPU. So that's an x86 node, and then the storage nodes themselves, we can use x86 or ARM, but ARM is a little bit more cost efficient in terms of performance to host and capacity to host. Yeah, so here we have a cluster UUID. I need to insert those into the statements. So for each of the storage nodes that we are adding, I have 3 storage nodes here. So basically, I'm telling them how many LVols, what's the max provisioning size, and then, yeah, some other parameters not so important right now. On the storage nodes, I have already, when I bootstrap them from AWS, I have a small agent running. So the control plane is on an M6i X large, and the storage nodes are on the i4G. So now I'm here having set up a cluster that is based on 3 storage nodes on the instance type that you can see here, i4G X large. So we have significant instance storage here. And the next step I'm doing, so first of all, yeah, let's list the cluster again. So I'm now creating a pool for that cluster, the storage pool. So you can create arbitrary amount of storage pools. For example, for different tenants, you can have different pools. So I'm adding a pool here. Let's say I'm not limiting it now. You can limit IOPS or capacity on the pool level. So now once I have a pool, I can also add LVols to this pool, and that's a process that can be automated. So that's actually the same now that you would do through API or through the console when you create an EBS volume, analogon, let's say. That's the same thing that we do here. We have more options, so LVol add, and let's say make it still easy. I'm adding an LVol, let's say size 1 terabyte, and adding it to the pool that I created. SPCLI dev, cluster activate, first activate one time the cluster. It's basically initially you add a number of storage nodes, and when you're ready, you activate the cluster, but you can add more storage nodes later on when it's active already. So if you want to grow the cluster, no problem. So now we have that LVol that's here now, and what I can do with it, show you something. That's all. I mean, for example, if you use Kubernetes, there is a CSI driver. CSI driver automates all that process. So there is a so-called PVC. It will auto-create the PVC and do everything that I'm doing through the API now is automated. But if you're on plain Linux, yes, you use API or command line interface. So basically, what I'm doing here, creating a connect string. So basically that's, and now I set up a client. Let me just go there and connect to that client. So one thing you have to do one time, this is Linux sort of, they are very slim on AWS loading modules. So I need to one time do that or add it to the group line. So, and now I can basically connect that volume, that 1 terabyte volume here. So you can see here, we have a new block device, 1 tera, close to 1 tera. And now, for example, I can format that. That's already the same as with EBS. And now just to demonstrate some of the IOPS here. Yeah, we have around 100,000 IOPS on this LVol, so it's already quite significant. So that's basically how it works. As I said, you have everything. Yeah, latency is around 330 microseconds, which is about 10 times better than EBS. That's it in a nutshell. So basically now you're ready to use that. You provision an LVol and you connect it. That's the same as you would do with EBS, actually. So what you can do, we have all types of things like snapshots and clones and backups. Let me demonstrate you that. So now we have that LVol. We had a little bit of, so that's done, that's instant. Basically now I have a copy and write clone. I can use that as another volume with the same content immediately. So it's also instant. And then we can do snapshots to S3. We also have storage tiering that will be released. It's not in this version, but it's coming now. That is not hot will go straight automatically from this cluster into S3 buckets so that you save further storage cost. So I wanted to show we have all the things that I showed you on the CLI level. They also exist here exactly on the API level, and that's how we automate it. So if you're in Kubernetes, we use our own API to automate all this provisioning and connection and so on in the background, so the users don't do that. But if you're on plain Linux or plain Windows, yes, you have to basically do that somehow, the administration process manually. There are a lot of more commands, as you can see in the back, but I think it doesn't make so much sense to go through more detail right now. Conceptually, what you can see is from the perspective of the client, it's pretty easy. All we did is we ran one command to connect the volume. So that's very similar. It's a different command, but it's very similar to what you do with EBS. So basically, you connect the volume, and from then on, you can use it like any other NVMe block storage volume. From the cluster operations, yes, of course, it's a little bit more complex. You spin up the control plane first. This is what I did when I create, and then I create, first you have a control plane, then you create the clusters on top of this control plane. So we did that here. We created one cluster first. Then you have to add storage nodes to this cluster. This is where I did a mistake. I lost a bit of time. Afterwards, once the storage nodes are added and the cluster is activated, it's ready to be used. That's from the cluster perspective. But then you can connect any amount of instances or also Kubernetes clusters into that single storage cluster.